Hello, everyone. Welcome to Database Management. This is week 7. In this week, we're going to focus on union and subquery, which is chapter 10 and chapter 11 of the textbook. And to help you understand what union and subquery really mean, I created this scripts, SQL scripts. The scripts will be put on the course homepage and for you to do the exercise. We have learned how to use join to combine columns from different tables. Now let's focus on combine rows from two set of results. To combine two sets of results by row, there are two requirements. First, the number of columns of each set should be the same. For example, if the first set had 3 columns, and the second set should also have 3 columns, and when you only have the exact same number of columns, then you can combine those 2 columns into a unified table. In addition to the condition that they have to be the same columns, same number of columns, the data type of the corresponding columns in both sets should be comparable. Like for example, if the first column in the first set is a text string, and then the first column on the second set should be a text or string as well. And the second column on the first set is a date. The second column on the second set should be date as well. Let's say the third column in the first set is number, and then the third column on the second set should be number as well, because otherwise there's no rules for the program to combine those. So we have to ensure that the data types should be comparable between the first dataset and the second dataset. Once we have the two requirements satisfied, we can use union to combine those two datasets. Basically, they're going to have the same number of columns, but the rows are attached from each other. Now let's look at some example of using union to combine rows from two tables. Again, we're going to use the sales order example database that we used in the past few weeks. And then in this particular one, we're going to use the customer table and the employee table. Let's look at it, what is in the customer table. In the customer table, we have customer ID, first name, last name, etc. There's a column called customer zip code. For the employee table, it has employee ID, first name, last name, etc. And there is employee zip code column as well. Now, what we're going to do is basically try to find the zip code that are actually from both the customer table and the employee table. Okay, and we know very easy we can find out the customer zip code from the customer table by using the query simply by these two lines, as we learned on the first week. Similarly, we can find out the employee zip code from the employee table by run only those two lines. And the result from these two lines or these two lines will be just one column, which contains the zip code. And the column name is customer zip code from the customer table and the employee zip code from the employee table. And because there's only one column for each part, and they're all both a character with at most 10 digits, 10 characters is the zip code, and they are the same data type. So we can union those two. Let's do that. We run this query actually it returns all the zip code for both the customer zip code and the employee zip code. But you may notice that the column name is actually called customer zip code, which is actually a standard for my SQL Workbench. Basically, if the two column names are different, at the end of the day, for the final data, that final result is going to use the column name before the union keywords, which is the data created from the customer table, which is the customer zip code. Okay? So you can see that from the customer zip code table, there are some duplicates, which means it keep there are actually no duplicates in the customer table or the employee table for the zip code. And I think it's easier to see the no duplication by order them. We're going to cover a little bit later. And because there's no duplication, and because union actually is going to automatically remove any duplicated rows in the final result. Let's say there are some zip code in the customer table and the same zip code in the employee table, and the union actually is going to remove any of the duplications and only have distinct values. So that's the union. But sometimes you want to keep the duplications when you actually union to data set. That actually can be done by add the all keywords after the union. So the same kind of code. The only difference is we add a all after union, which actually is going to keep all the rows, no matter whether they duplicate or not. So that's all the rows. You can see that there are indeed some duplications. And to make it clear, we can use parentheses to separate queries that generate different sets of data. Here is an example. I will return all the names and address for both customer and employee, and then order by their name. You can also use the order by to solve the combined result after you union them together. Okay, so in this particular example, we're using again the customer table and the employee table. We actually use a concatenation function to actually glue multiple columns together as one column. And we're creating the full name and the full address, two columns, from the customer table as well as from the employee table, and then unioning them together. After unioning them together, we can actually order the final results by the order by keywords here. Let's see. Okay, in this particular one, we have the full name, we have the full address, and now the data actually combined from two tables, as well as we keep all the record and then order the data, order the rows by the full name. One of the interesting thing is, let me see where it is. It's basically, you see there's a duplicate row, one customer as well as one employee. So this employee is also a customer. So that's we keep the duplications. That's why both of those two lines show up in the data. Okay, this is some basic operations we use union. And you may wonder, can I use the where keywords in a union? Actually, no. You cannot use, like, for example, order by and where the full name equal to something or in a particular filter, because union, you cannot do that in union. But you can put in your where clause within each select statement. That's no problem there. You can put in where clause for each each kind of like the subquery, but you cannot put the where clause here. It is not allowed in MySQL Workbench. And union actually can be used multiple times to combine more than two tables in sequence. And for example, in this particular one, we just combine the customer zip code and employee zip code. We can also combine the zip code with the vendor zip code as well. Use union all, which actually we use two union all to combine three data sets to have all their rows glued together. That's right. So that's we have the customer employee zip code as well as the vendor zip code. So union is a relatively simple concept. So basically you have one set of data, you have another set of data, you want them glued together. And to actually combine those two data sets together, you have to have the same number of columns for each data set, as well as the corresponding columns has to have the comparable data types. The best thing is it can be the same data type, but if they're not the same data type, if they're comparable within SQL, that's okay too. Okay, now let's move to the next topic of subquery. What is a subquery? Subquery is a select expression that you embedded inside one of the clauses of a select statement to form your final query statement. The first usage of the subquery is to return a table-like result set that can be used in a select statement. A table-like result is a set with certain rows or of certain columns. Let's see a few examples. You can actually see that in more detail what we mean by subquery and what we mean by inside one of the clause of the select statement. Let's use the sales order example again. In this one, we're going to use the order table and the customer table. Let's see what is inside the order table. In the order table, we have the order number, order date, ship date, customer ID, and the employee ID. In the customer table, we have the customer ID, customer first name, last name, etc., etc. And how about if someone asks us to find all the orders that shipped at a particular date and the customer's last name associated with that order? Okay, and from the order table we can easily find orders that are shipped for a certain date. Use the where clause and from the order table. And from the order table we can have the order number, order date, and ship date. But we do not have the customer information for that order, but luckily we have the customer ID in the order table. So we can use a subquery here actually to retrieve the customer's last name. That is, select customer last name from the customer table where the customer's customer ID is equal to the order's customer ID. So this is a subquery because this particular select segment is within the select statement. So this is an expression. This expression actually gave us the customer's last name with the same customer ID, and we know the customer ID is the primary key for both tables, so we know it is a one-to-one relationship. So we're going to have one customer last name for one customer ID. And let's write. After you write, we see all the orders that actually shipped at 2012 October the 2nd, and they have different order number, they have different order date, and they have different customer's last name. Okay, so this is one way we use a subquery. So this is called a subquery, and it is used inside one of the select statement. You may wonder, excuse me. You may wonder, we can solve this problem by using a join statement. Actually, you are right. We can use join, and this is another way to return. This is another way to return the same result. And in the above example, we inserted a subquery to return one column in the select statement. To make it clear, we use the parentheses to separate this subquery from the rest of the query. Before we go to the next usage of the subqueries, let's introduce a couple aggregate functions, count and max. Aggregate functions let you calculate a single value for a group of rows in the result site. Like for example, count star will return the number of rows of the result. Count column name will return the number of rows with non-null values. The max column name will return the maximum elements in the column. Okay, to illustrate those functions, let's look at the vendor table. Vendor table is a relatively small table. In this particular vendor table, we only have 10 rows and a few columns. And for the vendor web page, we know that for the 10 vendors, 4 of them actually do not have a web page. The web page is actually null. Okay, so let's apply the count star function, count vendor web page, and the max vendor zip code to see what will return. Here we know the total number of rows is 10, so the count star should return us a 10. And count vendor web page, and we know the vendor web page there are 6 non-null values, so it should return 6. The vendor zip code, those are the vendor zip code here, and it is going to return the vendor zip code that has the largest number. I think the largest number is 99209. Okay, based on what we learned from the table, we have the answer. But let's see whether the computer is going to give us the same answer. Actually, the count star returned 10, which means there are 10 rows in that table. The count vend web page returns 6. Out of those 10 rows, only 6 has a web page. The 4 have non-values. But this count variable name only returns number of rows that are actually non-null values, so that gives us 6. The maximum vendor zip code, as we can see, it is the largest number in the zip code, 99209. So this is simple introduction of the aggregate function. We're going to focus on more on aggregate function later, but basically the aggregate function will return one value from a multiple row result site. So as you can see, the vendor's data, it has 10 rows, but by using the aggregate function, there's only one row returned. The aggregate functions are very useful in subqueries. For example, still use the customer order example database. Show me a list of customers and the last date on which they placed an order. Okay, this is a little bit difficult concepts. What we want is the customer name as well as the last order date. And different customers is going to have different kind of last order date. So how to do that? Luckily, we have this subquery can be used to find those results. Here we have select customer's first name and customer's last name from the customer table. And what we need here is the last order date. How can we find the last order date? We can find the last order date from the order table. Okay, from the order table, we can select the maximum order date, which is the latest order date from the order table. And we can put in on condition that the order table's customer ID and the customer's customer ID should be the same. By doing that, we ensure for each customer, his or her own latest order date will be returned. That's right. So this is the subquery which returns the last order date. You can see that in the subquery, you can use tables that is not part of the original query. In the original query, there's only one table involved, which is the customer table. But for the subquery, we can actually get the data from the order table. That is actually you run the query, you can find out the customer's first name, the customer last name, and last order date. Okay, and you can see that there is one customer, there's no last order date, which means he or she didn't order anything yet. It's just a customer in the customer table, but there's no order date yet. Okay, that is one way to use the maximum aggregate function. In addition to the above example, where subquery can be used after select, it can also be used in the where clause as filters. For example, list all the customers and their last order number. In this particular one example, we're going to use the order table as well as the customer table. Let's see what is in the order table. We have the order number, order date, customer ID. In the customer table, we have customer ID, first name, last name, etc. In this particular one, what we want is to list the customer's name as well as their last order number. Their order number, for each customer, we can have multiple orders. And in this particular question, we want only their last order number. How can we do that? We can do that by using the customer table and the order table. We do the typical way. We select the customer's customer first name, customer's customer last name, and order's order name from the customer in the join on orders on customer's customer ID equal to orders customer ID. Okay, from the beginning to here, we have already learned this is basically going to return list of orders for each and every customer. So if the customer ordered 5 different orders, there will be 5 rows in the final result. But we only want the last order. How can we find the last order for each customer? Because the last order date or the last order number are all different for different customers. To do that, we can use the where clause, and in the where clause, we actually define the order's order date is equal to select maximum order date from orders as O2, where O2's customer ID is equal to customer's customer ID. Okay, in this particular subquery, we actually use the orders table again. But in this particular case, we actually put a name for this order called O2, and there's actually only one table within that subquery. But to make it clear, we use O2, and we actually define O2's customer ID is equal to customer's customer ID, and by using that, actually we only return the order number with the latest order date by using the maximum order date. So the order's order date, instead of to be 5 different orders, by applying this filter condition, is only return the order that actually placed the most recent. Let's look at the result. We have the customer name and order number, which means those are the customers who actually ordered, as well as their last order number. This is a very clever way to use a subquery to try to find out the latest order date information. We can also actually use the select statement as a subquery as the condition in the in clause here. In this one, we try to find out the customer, the list of customers where there are actually an employee in that particular city. We try to find out the customer's last name, the customer's first name, and customer's city, and for those cities only that the employee was in that city as well. So basically, this query returns the customer's first name, last name, as well as the city where there is at least one employee in that city as well. So this is a subquery used in a where clause where it is being used in the in keywords here. Let's see what will happen. Okay, so that's all the customer's name where it's in a city. In that city, there is at least one employee. Okay, so this is another way to show you how to use a subquery. The subquery is very flexible. It can be used in the where clause as well as it can be used in the select clause. Okay, that is all for today. And now there's homework. Please read through chapter 10 and 11 of the textbook and do the following exercise at page 372 and 414. See you next time.